Now, dear students, in this video, I am going to start a new topic, chapter number 13, probability, in the CBSE textbook 12th standard. In 11th standard itself, some introductory part of the topic probability you have been studied already. So I just recall the concept of probability first. For defining the probability of an event, we want a random experiment. Any tossing a coin, tossing two coins, or throwing a die. But these are the random experiments. On tossing two coins, the sample space S is H, HT, TH, TT. These are the four outcomes on tossing two coins. You will get four outcomes. All these four outcomes constitute the sample space. S is the sample space. So any event in the sample space is our favorable event, and this is called a random experiment. So while tossing two coins, getting two heads is a requirement event. Getting two heads. So HH is a favorable event. So probability of the favorable event E is the number of times that event occurs, favorable event divided by total number of the favorable elements in the sample space. Total number of favorable outcomes regarding that event is N of E. Two heads is 1 by the total number of elements in the sample space is 4. Therefore, the probability of our required event on tossing two coins, getting two heads, the probability for that event is P of E is P 1 by 4. This is called probability of an event. So, probability of an event should always be positive, and it lies between 0 and 1. Probability of an event should be a fraction only. So that is called axioms on probability. You have studied this axioms on probability. Axioms on probability. That is first axiom. Probability of any event should be greater than or equal to 0, but that probability should be less than or equal to, lies between 1 and 0. Probability of any event lies between 0 and 1. That means it's a fraction. And that probability any event is positive, should be greater than 0, greater than or equal to 0. So, the axioms on probability, any probability of any event should be a fraction only. Similarly, in the same event, if you consider the event E, favorable event E, by at least one time means HT, TH, TT. These three events are referred to be at least a time. If you consider an event by at least one time, these three events are there, favorable events. Therefore, probability of that event at least one tail is 3 by 4, like that. That's also a fraction. So, the probability of any event should be a fraction. It lies between 0 and 1. And S outcomes, probability, S is called the sure event. So, all the outcomes considering the sample space is called sure event. Yes is the sure event. Sure event. So, probability of sure event is 1. Probability of all outcomes in the sample space is P of S, that is 1. And probability of impossible event, that is not in the sample space. Phi is an impossible event. impossible event. Probability of an impossible event is P of pi, that is 0. Probability of an impossible event is 0. Okay. So, suppose probability of success is we define by probability of a successful event. That is successful event. That is P of E, you consider, is defined by small p, and probability of a failure is Q. Probability of failure event. That is called P of E dash. E is the success event. The exclusive of E is E dash. P of E dash is defined by Q. Probability of failure. E dash is the complementary event of E. P of E dash. E dash is the complementary event of E. So P of E dash is Q. So sum of this success event and failure event gives you the total sample space 1. P plus Q equal to 1. So from this we get Q equal to 1 minus P or P equal to 1 minus Q. These are the axioms on probability. These are the things you have studied already in your 11th standard. By keeping all these things in your mind, in this year 12th standard, we are going to continue the topic probability in our class in this standard. First, we are going to see conditional probability. Our first idea in 12th standard is conditional probability. Now, in this class, 12th standard, in the topic probability, our first definition is conditional probability. Further, we are considering a random experiment that is tossing 3 coins. Tossing 3 coins is a random experiment. The sample space is H, T, HTT and TTT. 1, 2, 3, 4, 5, 6, 7, 8. 8 favorable outcomes are in the sample space on tossing 3 coins. So on tossing 3 coins, this is the 8 outcomes considered constitute the sample space. Our event E is the event at least 2 hits. E be the event at least 2 hits appear. At least 2 hits. On tossing 3 coins, the event E is the event getting at least 2 hits. That is E equal to at least 2 hits means you consider all the 3 hits. HHT, and THH. So these are the 4 events constitute at least 2 hits. These 4 events consisting at least 2 hits. So probability of that event E, at least 2 hits event, is probability of favorable event N of E by N of S. The number of outcomes of favorable events is 1, 2, 3, 4 by total number of sample space elements is 8, that's equal to 1 by 2. So E be the event at least 2 hits whose probability is 1 by 2. Similarly, F be the event getting at least 1 tail. F is the event first toss is tail. E be the event such that the first toss first toss is a tail. F is the event such that the first toss is the tail. That means first toss tail. This THH, TTH, THT and TTT. These are the four events consisting first toss is a tail. So probability of that event of is P of F is equal to again 4 by 8, total number of sample elements is 8. So 4 by 8 is again 1 by 2. Now out of this event E and F, one event C, THH occurring both E and F events. Therefore, E intersection F is THH. E intersection F is THH. So, probability of E intersection F is equal to 1 by 8. This is 1 and N of S is 8. So, P of E intersection F is 1 by 8 because E and F consisting one event THH is a common event. Therefore, P of E intersection is 1 by 8. Now, the sample point of F which is favorable to the event E, this THHS is called the sample point of F which is favorable to the event E is THH. So that's our idea. Next idea. We are defining conditional probability. Remember? See, the sample point of F, the sample point of F which is favorable to the event E, which is favorable, the sample point of F which is favorable to the event E, the sample point of F which is favorable to the event E is THS. The sample point of F, that is THS, is the favorable event in E also, that is THS. So, that event is THS. The sample point of F which is favorable to the event E is THS. Now, the probability of E, the probability of E having F as a sample space, probability of E considering F as a sample space, probability of that event E, favorable event E, considering F as a sample space. Considering F as a sample space, is F as a sample space. The probability of E considering F as a sample space is P of E by F. The probability of E considering F as a sample space is P of E by F, that is equal to THS, sample space element F consisting 4 elements, therefore 1 by 4. That is N of E is THS by favorable elements in the F. Sample space F is 1, 2, 3, 4 elements, therefore this is 1 by 4. So this is again called probability of E given that F has already occurred. See, this is again equal to, we can say this is that is the probability the probability of E, given that F has already occurred, is P of E bar F, that is equal to 1 by 4. So this is called conditional probability of E. The conditional probability of the event E, given that F has already occurred. That is, this P of E bar F is called the conditional P of E by F is called the conditional probability of E, given that F has already occurred. F has already occurred. It is defined by a formula. P of E by F is equal to P of E intersection F by P of F. This is the formula for finding the conditional probability. P of E by F is P of E intersection F by P of F. You know P of E intersection F, 1 by 8. You know P of F, F consisting of 4 elements, you know P of F is 1 by 2, sorry. P of 4 by 8, that is 1 by 2. So this is equal to 1 by 8 into 2 by 1, that is equal to 1 by 4. So conditional probability of E, when F has already occurred, P of E by F is 1 by 4. So this is the definition of conditional probability. Conditional probability P of E by F is equal to P of E intersection F by P of F, where P of F is not equal to 0. In this formula, you remember that here P of F is not equal to 0. If it is equal to 0, probability doesn't exist. So therefore P of F is not equal to 0. Or otherwise, F not equal to 5. We can also say if P of F not equal to 0 means F not equal to 5. If F is equal to 5, impossible event is probability of F is 0. So P of F not equal to 0 means F is an impossible event. F should not be an impossible event. F is not equal to 5. That's all. So this is the formula for finding the conditional probability of E, where F has already occurred. That's all about the idea, the definition of conditional probability. I will stop here this video and we will continue the concept in the next video. Thank you.